Hello, good morning, good afternoon, good evening, wherever you are. Welcome to our LinkedIn live stream hosted by me, Peter Finter, our Chief Marketing Officer here at KX. And I'm absolutely delighted to be joined by Ashok Reddy, our CEO this morning. And we're looking forward to a really exciting conversation today about all that's news here at KX. We recently announced our emergence as a standalone enterprise software company. It's a big moment for the company. It's a big moment for all of our customers and for the market at large. It has lots of implications. We're going to talk through those implications today. We're going to talk about what's happening in the market, how KX intersects with that, and how we can help you take advantage of KX technology to transform the world in which you are operating. And here we are in the midst of an extraordinary time, a lot of volatility in the markets around the world, a lot going on. And this is a moment in time when KX has more to offer than ever before. So with that, I'd like to start, if I may, by welcoming Ashok, welcoming you as our audience and encouraging you, if you'd like to make comments as we go along. We'll be tracking and monitoring those and addressing as many of them as we can. But I'd love to start, Ashok, if you wouldn't mind, with just a little bit of an introduction and maybe a step back. Before this moment of emerging as a standalone enterprise software company, where have we come from? Maybe a little bit of the backstory would be great for us to start with, if you wouldn't mind.
Yeah, thank you, Peter. Thanks. Welcome, everyone. So KX started in, believe it or not, in 1993 in Silicon Valley. Arthur Whitney started this company same year as NVIDIA and focused on high performance data and analytics. And since then, the company has evolved from being a standalone KX software company and got acquired by FD Technologies in UK. And that has been the journey over the years. And just as Peter, you said, recently we have now the FD Technologies as a parent company sold other divisions, including the first derivative consulting business. And now KX has become a standalone company again. And it so happens we exceeded $100 million in ARR. And we've invested in a lot of the new capabilities, including AI and other things we can get to. But very excited. It's been a more than 30 years journey for KX.
Ashok, what is it? Thank you. What is it how would you describe the next chapter of the journey for KX at this point? It's been a storied 3 decades of working in capital markets and aerospace and defense and around the world, many different industries. As we look ahead, standing as we are today, what is it that excites you about this next chapter? And how would you describe it to our audience today?
Yeah, I mean, I think we are super excited about, one thing is as an independent software company, it gives us focus and it gives us full control in terms of how we can build faster, make sure that we can serve our customers and developers better, and deliver everything what we do in the KX is known for high performance data and analytics. And as we evolve that to AI in real time, how do we make it more accessible? Being able to, not just in capital markets, obviously, if you look at the type of customers we have, we are so proud in terms of, we talk about things like bulge bracket customers who are the biggest, most prestigious banks, investment banks. Every one of them is a KX customer. If you take the top 5 in Canada, in the top big 4 in Japan, and Australia, and Singapore, and London, every one of them is a customer. So it's a very proud heritage, but trying to bring the same thing to everything else. So we are starting to do that, starting with aerospace and defense. We have companies such as Lockheed Martin is now a customer, a partner of ours. We're bringing that to different markets, into high-tech manufacturing. So it's really about making it more accessible, the type of things we always have known for, and expanding the opportunities.
Thank you. We'll come back and talk a little bit more about what that means in just a moment. But I thought it might actually be helpful for us to explain a little bit more about this line that we've been using around survival of the fastest. We've been using that in all of our publicity and our communications materials, and of course we're known as KX as the performance leader in our market. We hold world records across the board. But what is it that survival of the fastest means to our customers, Ashok? Why have we picked that line, and how does that relate to the world that our customers are living in today?
Yeah, I think it's because it is the truth. When you look at, I like this statement by recently by David Booth, who manages the Dimension Funds, which is the largest money management fund. He said, if you're really going to beat the market, you got to be faster than everybody else in the market. We assume markets are efficient, but it's true in every industry. So KX is really about helping customers to act faster than their competition in terms of how they process, analyze. It's not about just the speed in terms of how you process data as much as survival of the fastest is about how do you actually innovate faster, how do you learn faster, and how do you differentiate yourself. And that to me is really the where it came from. It's really the truth in the sense our customers live every day. If you think about the last 2 days, what has happened in this past week, just based on the tariffs, every day it's becoming more and more critical where speed is what you start in the market in the morning. There's $2 or $3 trillion worth of changes have happened. And so that's the speed and how do you keep up and how do you make decisions faster than anyone else? How do you innovate, differentiate yourselves? So that's where the survival of the fastest comes from.
If I may ask, Ashok, as we think about the impact of AI in the context of real time decision making, and the world that we're now operating in, as you pointed out, is an increasingly real time economy, isn't it? And I'm wondering if you might make a comment on how you see AI informing and affecting that real time decision making environment. I think that would be helpful for our audience to understand a little bit about how KX is thinking about that and what we're doing about that, just to support this idea that making decisions faster, but they have to be the right decisions in the moment. How do we leverage AI to achieve that?
Yeah, I think the real-time economy means that today the delay in everything causes equals decay, and if you're really not acting in real time, as I just mentioned, I just saw news that there's almost $2 or $3 trillion worth of stock, changed just in a few hours. Something happened, some tweet happened, somebody heard something. The market is changing so rapidly. It's not affecting the stock market, but it's affecting logistics. It's affecting everything else in the world, every other economy. So in that context, AI, it's still thinking about today's AI. When people think about it, it's looking data as static. So what you really need is you need a more of a time awareness to AI because it needs to look at everything as a living stream. It's not just it doesn't just predict what it needs to understand when, how fast, and why. And that's what I think it's important to leap into what we call the temporal AI mix. Time aware AI is really about temporal AI. So you know when, why, and what happened, and how you learn from data as it changes. Data is not static. And that's really what, we think about what's happening in the market. And what we need to do is to bring that temporal awareness and temporal AI.
I think it's fair to say, isn't it, Ashok, that KX has always been focused on time as a critical element supporting decision making, and that's originated in what we've referred to as time series data, and the way in which time series data is different from other data types and how that it can be leveraged. But I think what we're observing is that time is becoming a factor or consideration in all kinds of data, not just in the classic and traditional time series data component, and that time context is the key to understanding how to make better informed decisions, recognizing what has happened in the past, what's happening now, and how to blend those two things together. Can you just say a little bit more about how you think about the use of how time can be used and needs to be used to support decision making in this increasingly real-time economy that we're operating within?
Yeah, it's a great question. I think part of the problems with, when you think about AI, people think about decision. It's really helping make decisions. And one of the key aspect of decisions is also about, what caused something. And if you make a decision, you need to know when it happens. So the time element is missing today in terms of what, especially in generative AI, because most of the things what the GPT and the transformer models are doing is they're learning by memorization, in essence, the patterns. And the longer the sequence is, the more data you have, it becomes harder for it to memorize or at least to learn the patterns. So that's where you end up getting hallucinations and others, because it's not designed for long sequences, especially time-oriented things. So you need to think about reasoning in a temporal inference. So when you bring time into it, everything has a cause and effect, and being able to explain, and all that is what time brings. So causal is by nature, something happens at some point, and then because of the result and dependency. So I think that's the really the key part is to temporal AI is not just for analyzing, but you want to look at the time aspects of it. And it's not just a column. Time in this case, not about time series data. Yes, you have time stamps, but how do you use time to look at different windows of time? It's almost like a time machine. You want to go back and play back what happened. You learn what happened in the history, but then you want to use that to inform what's going to happen in the future. And that sequence is not built into generative AI. And the longer it is, it's just the context window what everybody uploads. Yes, you may have some RAG and other things what people are using, but that context is not enough. When you think about the time, you may be able to look back 10 years worth of data or 5 years, or just want to compare points of time. What we learn with the time as an element, temporal aspect is a very key aspect of decision making.
I recognize that that there are two aspects to that are very important. The first is the ability to be able to combine data from different time scenarios. So yes, you've mentioned historical data. Maybe you need 30 years of data from the markets to inform your current decision making, because that will give you the most informed pattern matching to work from. But you need to combine that then with real-time or streaming information that is current, that is up to the moment, that can then be used to compare and contrast to that that historical data. So there's a piece which is about bringing the data together, but then there's a piece which is around analyzing that data and using tools and techniques to be able to make sense of it, and to do all of that in the moment, in the time at which decisions need to be made. Maybe you could say a little bit more about that last piece, the analytical component. What is it that makes KX different when it comes to analyzing data in the context of time than other databases would be able to achieve?
Yeah, I think it's the fundamental concept is here. Data, you don't start with the data to figure out what questions. I think the fundamental difference, what KX, we look at it is, what are the questions you want to get answered, and what type of data you need to answer the question? Because it's a different fundamentally, that means you're bringing analysis and analytics and AI to the data, not the other way around. Because most of the people that collect data, they try to figure out what answers can I get from this data. But it really is starting with questions to figure out, asking the right questions is very important. And in that context, you want to bring analysis as new information comes in. You're doing it at the same time. It's not about storing the data and taking the data somewhere else to analyze and process. One of the fundamental things we do differently is we are processing and analyzing and doing analytics at the same time, at the same place. So you're bringing analysis, analytics, and AI to where the data is, or when it's streaming, and being able to combine that together is how our human brain works. It's like you don't try to think about I need to bring historical separately, and then I do real time, and then how do I do analysis? I think everybody else has to bring process data, store data, analyze, visualize. I think we have a unified engine which brings that all together to basically ask the question, and if you want to interactively change the question, you are able to then look at the data differently and what type of data you need, whether it's structured, unstructured, doesn't matter, but it starts with asking the right question.
Such a different way of thinking about data, isn't it? I think historically we've always started from what data do I have, and now what can I do with that data? What can I get from it? As opposed to saying, what decisions am I trying to make, and how can data support that decision making? And what links in my mind to that is something we talked about at our capital markets summits back in the fall, which was the way that our human brains work in decision making ourselves. If we did not have the benefit of AI or technology to support us, what would we be doing? Well, typically our brains combine this idea of predictions with decisions or judgment. And it's the human judgment aligned to the predictions that our brains naturally perform to try and anticipate what should I do in this situation? What have I done? What have I seen in the past? What are the scenarios? What choices do I have to make? And then how do I make the best decision? It occurs to me that we are using AI now to augment that first part. Primarily, the judgment still remains with the human. We are the ones that ask the questions and need to get the answers, but that prediction component is where AI can make a significant difference to us, and we're all getting used to that. And I think one of the things that you pointed out in your writing is how interesting it is that our current GPTs, our LLMs, are actually not very well equipped to help us when it comes to math. In fact, I think you famously said ChatGPT doesn't do math. That may come as a bit of a surprise because you can ask ChatGPT to solve a problem and it will give you a mathematical response. What did you mean by that, Ashok? Tell us more about what's not there that ought to be or that we need to make the best decisions in our businesses.
Yeah, no, I think, generally, I think in terms of machine learning and deep learning, it's computational statistics, right? To your point, what AI in this case is, it's a prediction technology, and we are lowering the cost of prediction according to other, the really famous books around competing in the age of AI. So what we are doing is that prediction technology is lowering the cost of predictions, but you want to use that to help humans to make better judgment. So you can be data driven, but you can do different scenarios. But the second part of the thing, what you said is, there was a study recently, I think the University of Chicago did that. When you look at ChatGPT and why it doesn't do math, in the sense it's doing math. I think we all think it's doing calculations and math. It's not about doing math, but how it's learning during the training. It's using pattern recognition and memorizing those patterns. So if somebody has actually done certain calculations or memorized that the pattern based on that, but if you come up with new ways of asking questions, as I said, it's not able to go and calculate that. It's not a compute engine. What is trained on is what its users memorize the patterns. So that's where it falls apart, and that's what the study in the University of Chicago showed. So you really need to bring deterministic computational element and use that to learn patterns and combine that with generative AI, where it's really great in qualitative things, and you're able to bring that information together. And that's the reason why I said that Chat GPT doesn't do math or time, because these things it learns and remembers the patterns and memorizes them, but it's not coming up with new calculations or new learning from new calculations, and that's where we can supplement that.
And that's a great point, because generative AI clearly has a huge role to play. And we're seeing use cases that we support around AI-powered research assistants, for example, to your point, extremely good at concisely summarizing information and making it available in much faster ways than we could do without it. But as we think about how to combine generative AI into our business practices, where it's critical that we make the right decisions, particularly when we're in a compliance-orientated, regulated industry like capital markets. How are we thinking at KX about blending the best of generative AI with the other types of AI that we've been leading in for these last many years around deep learning, around discriminative AI or classic machine learning? How should we be thinking? How should our audience be thinking about bringing this together? And before I answer that question, let me just open to the wider audience here and say, if you've got a question and you'd like to ask Ashok something about KX, then please do put it into the live stream here, and we'll pick up on those, and we'll take some of those questions as we can through the rest of our time together. So Ashok, how are you thinking about bringing all types of AI together to support better quality algorithms and decisions in our businesses today?
Absolutely. I think if we start with, let's take quant research as an example. So quantitative research was all about looking at structured time series data, market data, and other things to make quantitative analysis, and you use machine learning and models to determine algo trading. It will happen based on the quantitative analysis. But one of the things with generative AI, what's happening is you're now able to bring a lot of the qualitative information. It's not just about structured data, time series data, but there's a lot of things happening in the market, whether it's earnings reports and things what's happening in the stock market, and there's things happening in the sentiment analysis. And these things, there's a lot more information happening in real time, and you can do that. And if you just do structured or just do unstructured, it's not useful by itself. But by combining, what we are seeing our customers doing is, for example, if you create a research analyst and you're able to take information, let's say from sec.gov, you have lots of documents from earnings reports and company reports and earnings, what else is happening in the market, you're able to convert that into structured vector embeddings, and you're able to use semantic search, similarity search to summarize information. But that's not good enough. And we can take that, and now you can combine that with quantitative analysis by saying, let's say I have a portfolio of stocks I'm recommending to a client on a sell side. They can now say, let me understand what these stocks are actually going to do, or what's the right portfolio mix. Then you're able to use quantitative analysis to combine that, and now you can take that and use LLMs to then be able to reason and figure out what's the right, analysis of the data I've got from quantitative analysis. So it's almost like a chain of thought. You can go and look at
Mm.
unstructured sentiments, combine that with quantitative, then bring back, the combination of this. And people are using agentic AI to actually automate that. So
Right.
agentic AI can do chain of thought process and be able to go all the way back to getting real-time information and be able to recommend a wealth manager, for example. If you're managing 100,000 clients, you can give them a specific advice to their own portfolio in real time to adjust that. And so that's the power of this, bringing generative AI as well as the traditional AI to combine and make it relevant, and now using agentic AI to automate that.
Yeah, it's a very powerful combination, and a lot of new tools and techniques needed to be able to address this, particularly at the scale that we're talking about. And I want to come on and talk about efficiency and why that matters and how GPUs play into that. But before we get there, we have a comment come in. Neil, thank you for making that comment. Can you talk more about how KX brings analytics to the data and how that benefits users and customers? We touched on this earlier, the importance of bringing data and analytics together because of the speed advantage that's required. And of course, there are cost benefits as well. But can you say a little bit more about why that matters so much and why the KX approach is different from others who perhaps come at it from a data angle rather than from an analytics angle?
Yeah, absolutely. I think generally, when you think about how the database is organized, or people get the data, they store data, and then they may have some stored procedure to some things to do that. But in order to do the compute or calculations or analytics, they'll have to then move it to somewhere else. So there's another product or whatever. In our case, it's really an analytical, computational database, which that means we are running in memory. It's columnar, but it's also functional. So you actually think about it as a giant real-time spreadsheet where you have millions and billions of columns of data, but you have functions. As soon as something changes, is these functions are calculating right in the spreadsheet. So it's really KX, KDB, and our platform is that. It's kind of a real-time, a giant big data and real-time data coming together. So you're not moving around, just like everything changes. And the other thing, what happens is it's parallelizing it. It's not about sequentially calculating things. So if something changes in a spreadsheet, you remember that you can change the whole thing. A spreadsheet can maybe have a maximum of 1 million rows. You can have billions and trillions of rows and billions of columns. All of it will be handled in parallel, and that's where the GPUs come in. You can almost have multiple tabs in a spreadsheet. Each tab can be assigned to a GPU, and you can run functions and run deep learning. And that's the power of it, being able to bring functional programming to array-based programming, which means you're parallelizing everything, you're running everything simultaneously, and making the most efficient use of both compute as well as the GPU to bring that very, very efficient way of handling data without moving the data around, which is inefficient, but also it creates a lot of costs and energy use. Everything is going to be efficient when you do this right where the data is.
Now, thank you. And you've raised a very important point, which is that GPUs have become the big news story of the last couple of years for certain, although they've been in development for as long as we've been a company in some respects, as you pointed out earlier. And of course, we've been partnering with NVIDIA to work with them to look at ways in which we can take advantage of their GPU technologies alongside of the more traditional CPU environments that we have traditionally been operating within. Perhaps you can help our audience to understand a little bit more about why GPUs matter alongside of the CPUs. How do you divide and rule? What do you do with a GPU that's different from what you do with the CPU? And why is it important to be able to think about both in an integrated environment?
Yeah, absolutely. I think generally the computational things, a lot of things in things what we do have a sequential way of processing things. Some things need to, it's like a master chef. Somebody is to coordinate and orchestrate everything when you're trying to make some recipe. But then there are things which need to be handed off to certain things can be done in parallel so that you can do a lot of things can be handed off. So that's where the GPUs come in is like graphical, when we came up with the graphics and graphic processing, those things can be parallelized. But in the context of whether you're doing algo trading or whatever, when you're doing real-time processing, there are a lot of things you can actually divide that up in your massive petabytes of data you're handling when you're doing certain calculations. There are some things you can do in sequence, but orchestrating, but you can use GPUs to delegate certain tasks and bring it back. So that's what we're doing with NVIDIA. Part of this is when you want to do market making and you want to do, let's say, liquidity creation for $100 billion worth of assets, but you are not able, you can do that historical information, you can create your models, but when you now go into real-time trading and you want to get order books, the only way you can do that is using GPUs to massively process as new information comes in, update the models, and combine that together. So that's what we're doing with NVIDIA. And the other part of it is there is a bottleneck between GPU as a CPU. So when GPUs, as fast as they are, they can parallelly process everything. But the data transfer, the memory bus data transfer between the CPU and GPU is a bottleneck also. So that's where the new next generation architectures like Grace Hopper and Grace Blackwell have come in with shared memory, where there's a high memory data bus, and KX is very good at that, right? We can actually parallelize everything and remove the bottleneck between the CPU and GPU, and we can have what we call a zero copy feature where we don't have to move the data and be able to process again using GPU. Certain things run in GPU, and we have implemented some key functions such as of join and window joins now to take advantage of GPUs. So what that does is, if you are running back testing or whatever, which may have taken a week right now, where you're trying to compare multiple models, you can do it in minutes with a combination of NVIDIA GPU architecture with KX.
And that compares to the hours that it takes today. I mean,
Days,
I've heard
in many cases it's
even 100
days.
times improvement in performance. Ashok, is that the kind of expectation that we should be setting for our clients, that they could improve their back testing capabilities to that order of magnitude? Because that seems to be transformational. That changes the way that you can iterate on strategy development. This accelerates innovation. This gives you that alpha, the edge that everyone is looking for. Really stems from your ability to process this data more rapidly in order for you to explore more strategies, test those strategies, and then implement them ahead of the competition. How do you think about the difference that this can make to our clients, Ashok?
Absolutely. I think most people, when they think about whether it's a back testing or whatever, it's not just about just starting with one strategy and looking at what happens. And now with the number of models, we are moving at the speed of thought right now. The number of changes happening. Every company, before you test something and people want to know there is another model and I want to test, how do you know what's the most accurate model you can use with the least amount of hallucination? So you may want to do a hybrid things. You may do an ensemble of models, and all that takes a lot of compute, a lot of time and GPUs, and people don't have enough time and effort, and then it takes consumes a lot of power. So that's where this becomes much more important, the efficiency part and the having very little latency. Because let's think about what happened with the DeepSeek, right? It's not that they're the best model or whatever compared to others, but they were the most efficient. They were able to do that with the least amount of resources and not even maybe using all the full power of GPUs. So if you are able to do that with when you compare multiple models, and instead of taking days I've heard customers say they're able to find alpha now instead of taking, say, 10 months, a year. It comes down to less than a month for them finding more alpha in some of the market is constantly changing. So that's how it translates to edge is what alpha. How can I beat the market? And when it's constantly changing, and even though the market is efficient, again, it comes back to the survival of the fastest. In this case, it's about the fastest who can find the alpha and continue to find the alpha, which means it's differentiated. If I just put my money into money market funds, I can get 4%. How can I beat that? A risk, it's a risk adjusted return, and then I need to beat my competition. So that's what we find. Some of the best, the top hedge funds in the world are all using KX technology. Same thing with some of the biggest investment banks, even in other industries. But that's because they're able to try out different aspects and different models. And now you're bringing structured, unstructured together, and also look at the temporal aspects of it, which is one of the key fundamental missing piece of this.
And it's a powerful combination of capabilities that we bring together for this purpose. If you were to answer a question that someone would ask who is new to KX, what is it about KX that makes it as so efficient compared to the alternatives? In a nutshell, Ashok, how would you respond to that?
I think our advantage is really it's more we have built this a unified platform where we are able to process information. As I said, everything is done simultaneously as one thing, and it's built to take advantage of how computers and the infrastructure is set up. It's not about trying to build in loops. For example, people do a lot of calculations and they need to have loops. In our case, we're doing everything to take advantage of how memory is organized, how information is processed. So being efficient means that you want to use the least amount of not only the memory, but even when we actually store data, we compress it and we are doing it in columnar. We are able to use, or for example, when people do queries in SQL, if you give you an analogy of a spreadsheet, you have to load up every row before you can do a SQL query to even when you want to do this thing. We actually look at a columnar, we can pre-filter things, and you only want to look at the data and the columns what you want. And having that in memory, but then even if you don't have all of it in memory, we are able to bring data, compressed data from stored information to combine that. And as new information comes in, the streaming aspects, you don't have to have a separate streaming engine and be able to move the data somewhere else. So bring it all together. So it's having that unified in-memory, columnar, functional programming, array-based thing is what makes it superior. And at the end of the day, our core technology, KDB Plus, is still less than 1 MB of it uses memory and only a few hundred lines of code. And it has been proven for 30 plus years. We never break the code when we upgrade. It never breaks things. And it's least amount of energy use also. So that's what makes it very efficient, but also the most performant, ultra low latency computational and data analytics platform.
It always comes back to the architecture, doesn't it, Ashok? And the genius of Arthur Whitney, who started the company all those years ago. We're still building on that foundation and finding new applications in a remarkably similar way, I think, to Jensen Huang over at NVIDIA, building on the foundations that were laid even in the very first product that they brought to market. The time is right. The time is now. It seems to me that we're really well positioned to capitalize on that and to bring the advantages that you've talked about, that completeness of data, the structured, the unstructured, the historical, the streaming real-time information, together with the timeliness associated with ultra-low latency, the ability to use time to help us understand data and analyze data and to deliver that in an efficient way that ensures that it's possible to perform at higher scale, being able to take advantage of these new data sources within the economic constraints that we're operating under, and with an ability to use resources efficiently to accomplish the goal. So it's a powerful combination, and it seems very necessary as we think about the changes that we are witnessing, the real-time economy that we started with, and the world that our customers are operating in now, not just in capital markets, in aerospace and defense, and right across a wide variety of industries. You've touched on a very important thing just now, Ashok, which is the power of KDB Plus. And we held a meetup just a week or two back in London and another one in New York, in which we made an important announcement. Would you like to just share with us what we communicated in that session around KDB Plus and what we're going to be able to do with that, and what our customers and our developers are going to be able to do with that moving forwards?
Yeah, absolutely. KDB Plus, has been always known. It's beaten every benchmark there to be the world's fastest time series database and analytics platform. I think one of the things what we have done now is to not only for the time series structured data, so now we have brought in what we had in AI, the KDB.ai portion, unstructured processing, unstructured data in the same engine. So you're able to now bring both structured, unstructured together, and then bring Python, PyKX, what we used to have as a PyKX as an offering. Now you can do Python. You can process data such as Parquet and open data formats, all in a very easy to use user experience from a developer's perspective. So what we are doing is to really offer that a community edition for commercial use free. It's in tech preview right now, and it was never done before. We always had it for personal use, with KDB Plus. This combines structured, unstructured with all the things about temporal AI, time series AI, with Python support, with support for things such as Parquet and ANSI SQL, all available in one unified platform for commercial use. It's now going to be available as a community edition. So I strongly recommend for those of the community and developers who are listening to this or watching this to sign up on kx.com. And I think there's a URL for that. But that's really exciting. I'm really excited about what it will to help. Would like to see what developers can do and what they can build next in this new era of AI.
It is extremely exciting, and being able to make it available to everyone to take advantage of at no cost to them, I think is a huge step forwards for us, and perhaps one of the key markers of what it is. What does it mean for us to be a standalone enterprise software company? So I'm extremely excited about that. If you want to sign up, please go to kx.com/research, and you'll be able to register your interest. We are still working on making it available over the next several months. It will be available very soon. So we'd love to have you become part of our early exposure to the product. So please do sign up if that's of interest to you. And we can't wait to find out what you can do with this extraordinary technology. I'm going to finish us up here by asking you one final question, Ashok, which is what you're most excited about at KX as we look ahead over the next few years. What is it that gets you excited about the future that KX is opening up here?
Yeah, I mean, I think, for us, it's really about making things which are impossible for our customers possible. I think, when I look at the type of use cases, we recently, the type of things, what I just said, this will open up for people to implement this, not just what we always have been known for in Wall Street, but in the Main Street. So, as an example, Lockheed Martin, as CEO for UK and NATO, posted something around how they were able to transfer data. They did an experiment to say F-35 planes, which are some of the most advanced stealth fighters. They have so much data, and being able to transfer the data from real time to the ground and then being able to share that across allied forces, they were able to do that all encrypted and in live, and that enables to do so many things. So those sort of things is what excites me, is the art of the possible. Where what are the impossible things? We've got things happening in life sciences research. People went from finding COVID vaccines in 6 years to 1 year to now. You're trying to find things much faster. So those are the type of things which is really exciting. Is the temporal AI, that bringing able to bring time as a key element of decision making, which we believe that we have learned over the years, and now we are able to now bring that missing piece of the puzzle to AI. The real-time temporal AI is what I feel. We are very, very excited to make it, democratize it, and bring that so that people can take advantage of it to make decisions in real time.
Thank you, Ashok. It's been wonderful having you with us for our live stream this morning. I hope everyone has enjoyed the conversation. To find out more, please go to kx.com and you'll see a blog that Ashok posted entitled "Why Breaking AI's Sound Barrier Will Drive Innovation." Some really interesting parallels with the aviation industry that you might not have thought about. So please do check us out. Come back to kx.com and we look forward to meeting with you on an upcoming LinkedIn live stream. Thanks everyone for joining us today. Have a great rest of your day.
Thanks everyone. Thanks, Peter.